Hello, hello. Thank you for this introduction and a very warm welcome to those two sessions on the Hindu Kush Himalaya. As already mentioned, my name is Katrín Jakobsdóttir, and I will set the scene for those sessions as the chair of the Polar Dialogue within the Arctic Circle Assembly. However, I would like to look a little bit back because during my time as Prime Minister of Iceland, Iceland and Chile co-chaired an initiative on melting ice. Iceland being very close to the Arctic, Chile so close to Antarctica. However, the novelty in that approach was that it was holistic and not regional. The initiative aimed to ensure that the irreversible and devastating impacts of cryosphere loss are understood by political leaders and the public alike, not only within the polar regions, not only within the mountain regions, but around the globe. And today we are going to talk about exactly that, about the interconnection of ice, a session organized by EasyMod, and a session on interpolar dialogue organized by the Ocean Policy Research Institute, the Sasakawa Peace Foundation. Now, to set the scene, very shortly before we start our sessions, I would like to be absolutely clear. It's of vital importance to approach the cryosphere in a holistic way. And this has been my view for many years. When we talk about the Arctic, we must remember that what happens in the Arctic can affect the whole globe. If we think about climate change in general, it will have an effect on the whole globe, and climate change is happening at an exponential pace in the Arctic. If we talk specifically about this area here, the Himalayas, the Himalayan glaciers help regulate the water supply for more than 35% of humankind. Yesterday, we had a great session here in this room on the possible effects and consequences that climate change in the Arctic is having on Asian weather systems, among them the monsoon, which is of course something that can also affect food production here in India and in other places in Southeast Asia. If we continue to talk a little bit about climate change in general and the melting of ice, we can also see the great thaw unfreezing vast areas of permafrost, releasing methane, a potent greenhouse gas. But we might also see some unknown bacteria released with unpredictable impacts on our health. And the climate change in itself, which changes really the whole of our environment, can also change the spread of infectious diseases around the world. The melting of the ice, which in long term might result in somewhere between 7 and 40 meters of sea level rise. The last report actually on the state of the cryosphere from 2024 notes that melting Greenland and Antarctica ice sheets may be slowing important ocean currents at both poles. And this has an effect on my home country, Iceland, because this could potentially have dire consequences for a much colder northern Europe and the greater sea level rise along the US East Coast. Now, the Polar Dialogue, which I chair, has the clear goal to convene scientists and policymakers to talk about the melting ice around the world and facilitate international dialogue and collaboration to tackle those severe challenges. And we have been talking about the importance of scientific collaboration during these 2 days because it's under pressure simply because of the geopolitical tensions around the world. The Polar Dialogue derives from the Polar Summit that was held in Paris. The first formal session of the dialogue was during the Arctic Circle Assembly last October. Our next stop was at the Abu Dhabi Sustainability Week, and we got to know the Emirates Polar Program here in a session yesterday. Now we are here in Delhi, again leading together experts and policymakers from different parts of the globe, facilitating science diplomacy and establishing people-to-people relationships based on scientific cooperation. I've been following the Arctic Circle Assembly since its beginning. And the strength of the Arctic Circle has always been its adherence to democratic values and its hands-off approach in fostering real dialogue. And the strength of the Arctic Circle events and initiatives, including the Polar Dialogue, lies in its flexibility, its non-partisan, non-governmental approach to fostering science diplomacy and science cooperation. And in these turbulent times, such a platform has become more important than ever. Now, I will tell you very shortly about these two sessions that we have ahead of us. Our first session today focuses on the Hindu Kush Himalaya Karakoram. And as already mentioned, the Himalayan glaciers are, we could call them the water tower of Asia. Yet it remains one of the most data-scarce regions on Earth. And we heard from the Director General of ICIMOD today and yesterday, where he mentioned that we are only short-term monitoring 38 out of around 40,000 glaciers. The permafrost observations are limited, and we have sparse high-altitude meteorological data. So we will learn more about the possible hazards deriving from this situation and what we can do to actually change that, both because we need positive climate action, we need to do what we can to preserve the Himalayan glaciers, but we also need early warning systems to actually prevent damage being done to those people who are living there in these mountains. Now, I'm very much looking forward to listen to this session because we need to create actionable pathways in alignment with the upcoming decade of action for the cryosphere, and there the Himalaya region will be very important. We need to talk, to have that dialogue to be able to better protect the communities, ecosystems, and investments from escalating cryospheric hazards. The second session, I will be participating in that, so better not say too much, but that's the Interpolar Dialogue, a strategic initiative aimed at fostering structured collaboration between the Arctic, Antarctic, and the Hindu Kush Himalaya region to enhance climate governance and policy coordination in the world's critical cryosphere regions. And as already mentioned, this region, the Hindu Kush Himalaya region remains underrepresented in international climate governance, leading to fragmented policies and inadequate adaptation strategies. I'm looking very much forward to participating in that session where we need all hands on deck to do what we can. So without further ado, I suggest we start those two important sessions. Thank you very much.
Good afternoon. I think Katrín has set all the background for this session, so thank you very much. And over the last 2 days almost, we have learned a lot about the connections between Arctic and the Himalaya, how they are connected through air, and politically and business-wise as well. So in this session, actually, we are going to talk a little bit about the science we are doing in the HKH region, that is called Hindu Kush Himalaya Karakoram region. So I am Mohammad Farooq Azam, and I am Senior Cryosphere Specialist at ICIMOD. Today we have our distinguished panelist here. So I will start with Dr. Pema Gyamshaw. So Dr. Pema Gyamshaw is DG ICIMOD. So he has been serving ICIMOD for last 5 years, and before that he served Bhutan for last three decades, holding different positions from natural resource management in forestry department, agriculture department, and he also worked as the first Minister of Agriculture and Forest in Bhutan. Then we have Professor Anil Kulkarni. So Professor Kulkarni is a distinguished scientist at Divesha Center for Climate Change, ISC Bangalore. And he is a leading glaciologist in India. He has published more than 150 publications, some of them including some key publications in Nature and Science journals as well. So previously he worked around 30 years at ISRO, and together he's bringing almost 5 decades of expertise here that has shaped the Indian glaciology. So then we have Dr. Aparna Shukla. So Dr. Shukla is a scientist at Ministry of Earth Sciences, and for last 2 decades she has been working through remote sensing as well as ground observations. So she has published more than 50 papers, and she has influenced lots of young female scientists in the region who took their career in glaciology following her. Then we have Professor Rijan Bhakta Kayastha. So he is a faculty at Kathmandu University. So he is bringing almost 30 years of experience. He has published around 100 papers. And together with EC Mode, he has developed a master program in glaciology that is the unique program in this region in glaciology. And that has produced several young glaciologists in the region. Then we have Mr. Safi Hassan Rizvi, last but not the least. So he is the advisor of National Disaster Management Authority. And I just learned that a couple of days ago, he also took the charge of NIDM. So he is basically providing the policy recommendations, prescriptions to Government of India, mainly on disaster risk reduction. And before that, he also served as a Special Director of Ministry of Home Affairs, and previously also worked as IPS officer in different parts of India. So with this introduction, we understand that we have a very enriched panel here, ranging from hardcore science to policy. And we start this session now, and I request Dr. Pema Gyamsho to have a 5-minute opening remark.
Good afternoon. I think yesterday, if you recollect, someone said we have only one planet. And I think that is the reason why we are all gathered here, and to see how we can connect with each other, connect across the globe, across various ecosystems, and see how we can protect this planet. And in our discussions, we always have to keep in mind that we are thinking about the future of the planet, future of the future generations and generations that will come after us. Now, we often hear about the limits that the planet could provide, the goods and services, the planetary boundaries. But when you talk about that, then we need to think about, okay, what did we inherit from our forefathers, foremothers, if you like, ancestors, and what kind of planet that we want to leave behind. And I think that is the question that we all have to ask ourselves, because like it or not, it is our generation, I think, that have to think for several generations later, future generations. So ICMOD, the International Center for Integrated Mountain Development, while we are focused on the Hindu Kush Himalayan region, we also try to learn from other regions, not only the 2 poles, the Arctic and the Antarctica, but also from the Alps, the Alpine region, the Andes region, the Carpathian region, and of course now more intensively we have been engaged with the Arctic Circle. And of course learning from the Arctic Council, its governance structure, and how we can learn in terms of building cooperation, in terms of building an institutional mechanism to strengthen regional cooperation. We are also looking at how we can engage in exchange of scientists, good practices, policies, learnings across between the Arctic and the Himalayas. So already we have had several exchanges, including the partnership with several of the agencies, the institutions in the Arctic countries. We have a very active partnership with NVE, the Water Resources and Energy Directorate of Norway, for example, the Stockholm Environmental Institute in Sweden, and several other universities and so on. So we need to learn from them and also share our experiences with them. Similarly, we receive substantial support from the Arctic Circle countries. I could name at least, several of them: Norway, Sweden, Canada, Finland, and we hope that this partnership will broaden further, and people to people, university to university, institutions to institution, and of course government to government, and scientists to scientists. So with this, I think I will stop at the moment and come back later. Thank you.
Thank you very much, Dr. Pema. So now I would like to request Professor Kulkarni to give a brief talk about the status of HKH cryosphere. So can we please have the presentation?
Good afternoon to all of you, and I would like to thank EC Mode for inviting me to participate in this workshop as well as make a presentation on state of the Himalayan cryosphere and potential hazards from the depleting cryosphere. Since yesterday we were discussing about that polar regions are warming much more than global mean. Here in Himalayas also, Himalaya is also warming significantly higher than the global mean, and here you can see when the early part of 50s and 60s, Himalayan region was much more global than the Indian Peninsular region, and as of now it is substantially higher than the Indian region. As a response to that, Himalayan glaciers are retreating, and they are retreating in very fast rate. So you can see here is a Pindari glacier which was photograph taken in 1936 and 2006, and how the glaciated area which was in 1936 has completely retreated and very small portion of glaciers remain on top. So there should not be any confusion in anybody's mind that Himalayan glaciers are retreating. However, their retreat is not uniform throughout the mountain range. It is varying, and it is varying depending upon which part of Himalaya you are. So if you look into the Brahmaputra basin or Ganga basin or in Western Himalayan basin, it is around 15 to 16 meter per year glaciers are retreating. But if you go up high into the Karakoram, it is retreating much more lower rate, which is around 0.3 meter, and this is known as the Karakoram anomaly significantly. But it is also important for us to understand how much is the glacial store water in the Himalayas. And you can see here that highest number of glacial store water is in Indus River basin, and then it is in Brahmaputra, and quite less, around 600 cubic kilometer water in Ganga River basin. So cumulatively, we have around 3,000 gigaton of water stored into the Himalayan region. But this is melting very fast, but melting is different in different parts of Himalaya. If you look into this picture, where the red you can see here is predominantly in the western river basins, Western Himalaya, and which is in Satluj, Beas, and Ravi basin, which is substantially melting at higher rate. And as compared to the Karakoram mountain range, particularly into the eastern Karakoram, glaciers are quite stable, and you can see there is a blue color, which suggesting that glaciers are not losing mass at significant rate. And that is precisely the reason we talk about the Karakoram anomaly. But this luxury may not last for very long time, but let us understand what is the long-term risk due to the retreating glaciers. So one of the key things here is to understand is how glaciers are melting and how they are likely to melt in future. So if you look into the eastern Himalayas figure, you can see here that already glaciers mass loss is quite significantly negative, and glaciers are in really quite retreating mode. But as compared to that, if you look into the Karakoram mountain range, glaciers are as of now have a positive mass balance, but by the middle of century they are significantly going to lose its mass. And particularly in Western Himalaya and Central Himalayas, glaciers are already having negative mass loss, and that can continue to have that mass loss in future also. So as the consequences of that, one of the key things is going to happen is very small glaciers. This is one small glacier, Camus village. Around that, glaciers are going to disappear very fast by the middle of century, and many such communities are now required additional source of water. That is why government has a concept of ice stupa, which is introduced by many places in India, because that is adaptation strategy, which is adopted by the government of India to do it. But as the glaciers start retreating, they create large amount of lakes, and such lakes can trigger because of various reasons. Either they can be flash flood can be triggered because of earthquake, because of landslide, or because of ice avalanches. Whatever could be the reason, such can happen, and huge flash flood can take in downstream. And this is the one work which is done by Indian Space Research Organization clearly suggests that we are now have large number of such lakes forming into the Himalayas. This is one basin, is the Indus River basin, where thousands of such lakes are being formed now. And we really need to critically analyze this thing. And recently we had a very flash flood in Chungtang village, where one hydropower plant was completely vanished. And this has happened in October 4th, 2023. So we have to be really careful and watchful about this new risk which is coming to the mountain glacier. There is also new risk which is coming into the mountain because of the flash flood from hanging glacier. There are thousands of hanging glaciers in Himalaya, and due to degradation of permafrost, such hanging glaciers likely to fall and create flash flood in downstream. And this has particularly happened recently, a few years back in Rishiganga Valley, where you can see the February 6th and February 8th, how much one hanging glacier has fallen down, along with debris and rocks, and creating a massive flash flood into the Rishiganga Valley. An entire hydropower plant was vanished because of that. But it's not only one or two such hanging glaciers. There are hundreds of such hanging glaciers in Alaknanda and Bhagirathi Basin, which is part of central Himalaya. As you can see here, so one has to be very careful and watchful about the new risk which is being generated in Himalaya. In addition to that, there is also one new risk is coming into the mountain, is the landslide from moraines. So as glaciers start retreating, they actually produce a lot of moraines. They are generally called lateral moraines, and if there is heavy rain into that region, there could be landslide, and this is particularly what has happened in Kedarnath Valley, where such landslide have taken place and created a temporary lake. It was busted and creating a massive flood. Of course, that was associated with very heavy weather condition in North India in June 17, 2013. And there is a devastation. The Kedarnath, you can see before and after how huge amount of loss to the human property and life has taken place during that time. In addition to that, we also have to realize now that the significant amount of development activities are taking place into the Himalayas. And we have opened up many mountain passes. We have created new tunnels so that one can move from one valley to another very smoothly. And winter tourism is now major pastime in India. So a lot of people are now moving into the mountains in the middle of winter, and because of sometimes the road conditions not very ideal, it creates a lot of dust, and that dust as well as black carbon coming from exhaust deposited into the adjacent snow packs, and it is significantly reducing the snow albedo. And the reduction in snow albedo is causing early melting of snow, and snow is departing much earlier now into the mountain than it used to be previously, and it has consequences. It has consequences because now we have very early snow melt leading to the early forest fire. So forest fire season, which used to be started much later on, April and May, now we have in month of March itself. So this is one photograph when I was in March into the mountains. I have taken that forest fire season was started in the first week of March itself. So this is a new thing which requires a new strategy for forest fire management. In addition to that, now since snow is depleting very fast and very early into the spring, the mountain springs are becoming dry now. So this is creating ecology of entire mountain region because springs are becoming dry and there is a shortage of water. So all these changes are taking place, and because of that, last year we had one major conference at Indian Institute of Science, and we had a lot of discussion there how we are going to manage this new crisis which is building into the mountains. So we thought that two new ideas we thought we can discuss. One is elevated warming in the Himalaya has intensified hazards in the cryosphere. We should convert hazard, vulnerability, and risk assessment into high mountain regulation zone. We already have coastal regulation zone, but we do not have high mountain regulation zone, and we nearly regulate development activity in high altitude region. In addition to that, until now, when we have any development activity into the mountains, we generally have an environmental impact assessment report, but that is not enough. Now we require the cryosphere change impact assessment report before even you can consider this any development activity into the mountain. So with this, we have to look into entire development activity in mountains very different way, and we require a new policy prescription so that we can safeguard our infrastructure and livelihood of people into the mountains. With this, I would like to thank and stop here. Yeah.
Thank you very much, Professor Kulkarni. So yesterday we saw that the global warming is actually giving different impact in Arctic region. Some of the regions, they are warming at very high rate, up to 6 times or sometimes 10 times than the global warming itself. Similarly, you highlighted today that there is elevation-dependent warming, and the impact of climate change is not uniform across the Himalayan glaciers. So, and you have touched almost all topics ranging from impact of tourism to hazards, which have been very important recently. So now we start this panel discussion. So I am having some questions for you, and I request you all to limit your answers and within 2 minutes, so that we can have enough time towards the end to have some questions from audience. So in the same line of your presentation, I will start with you, Professor Kulkarni. You have touched almost everything, but I would like you to put some light on how these glaciers are changing and what is the impact on the future runoff, how it is going to change, and what will be the implications on hydropower and irrigation in this region.
See, if you, in my presentation, I have said there are two things are happening. One thing is happening is glaciers are retreating, and they are retreating fast. But that retreat is not uniform throughout the mountain range. So you take for an example the south of Pir Panjal mountain range, where the streams are there, Satluj River or Beas River, where the glaciers are melting very fast. And some of the modeling studies which we have carried out suggest that as of now, long-term changes, the runoff which is coming from glaciers are now increasing, and this increasing trend will continue till the middle of century. And our model suggests that after this will go up till the middle of century, and then it will start falling down. It will fall down very significantly. Other basins like Chenab or Upper Indus River Basin, their glaciers are not yet started to melt significantly. So if you look into the Upper Indus River Basin, which is the northernmost basin into Karakoram, and from Karakoram that river is originating. Glaciers are not yet started to melt significantly, and because of that we called it Karakoram anomaly. But this is very temporary in nature. Models suggest that by middle of century, these glaciers start melting and their peak discharge will start till the end of century. I don't know what will after the end of century because our models have not predicted that, so we don't know. So by the time these lakes or these rivers which are south of Pir Panjal mountain range will mostly gone by the middle of century, then only the higher reaches glaciers will start melting and producing significant amount of water. That is one part of story is going to happen. Another thing is going to happen is if you really look into the this hydropower generation, there's a significant changes in hydropower generation going to take place in mountain. Essentially because it depends upon what kind of engineering designs you have made. Some will be very profitable after middle of century and some will become very unprofitable. There's a lot of work has been done into understand. So it depends upon engineering design, so you can be profitable. So how you can make the climate friendly design of hydropower plant is also a key question. So I think this is going to have a major changes, and the mountain communities will be forefront of this problem because you don't have villages near the large glaciers, you have villages at the small glaciers, and small glaciers are going to vanish very fast. So we now need to invest significant amount of money into the mountain to make sure that their livelihood is maintained. There will be water somewhere, but existing water supply strategies are not going to work. We need to invest significant amount of money into the mountain now.
Thank you very much. So now I would like to move to Dr. Shukla. So we heard that Himalaya is a third pole, but it is different than other two poles. Similarly, it is also different than other mountain range on the planet Earth. And that brings some specific set of challenges working in these mountains. So you have worked on ground actually. So I would like you to share your experience, how these challenges in the Himalaya complicate the glacier monitoring on ground.
Yes, thank you, Farooq. So namaskar and good evening to all of you. This being my first intervention, I'd like to thank EC Mode for organizing this important session, and Farooq, of course, for conceptualizing this and having me in it, and ORF and Arctic Circle for bringing this forum to India. The very important discussions we've been hearing since yesterday. Now to structure, my response to this question, I would be structuring it in 4 points. So first and foremost is the accessibility. We all know that Himalayas are the youngest mountain chains. And having said so, they are, we all know they are still rising with an approximate rate of 5 millimeters per year. And with this, we know that this entails that they have a very rugged terrain. And the access to most of our glaciated regions and glaciers is very arduous, is very difficult. This, together with the stringent norms which exist for selection of glaciers for the field studies. So Farooq knows that there are some set norms when you go out, when scientists choose their glaciers for field studies. So there are some strict norms. That together with the accessibility, because the glacier needs to be accessible. There need not be huge. If there is a huge trek, then it will be difficult. Then this together with the stringent norms, it complicates the glaciers, the field glacier studies, because often what happens is the glaciers which are ultimately chosen may not actually represent the region. That is one. Accessibility also complicates the monitoring of glaciers in Himalayas in the second way. That is, as we have been discussing in the last session related to the energy, that these regions often may not have very good accessibility, road networks, or power supply and interconnectivity, which introduces issues related to when we are going to install some automated instruments or equipments for measurements. So this actually adds up to the scarcity which we have of data. So the data is we are not able to collect the data in time. So this is about accessibility. The other quality which is inherent to Himalayas, or the Himalayan Karakoram region, as we Hindu Kush Himalayan region as we are talking about. So that is the diversity in the glacier types which we have, as Dr. Kulkarni has been also talking about, that we have diverse type of glaciers in Himalayas. Some are hanging glaciers, small glaciers, large glaciers. Then there is diversity in the debris cover types. Some are clean glaciers. Then there are partially debris covered glaciers and fully debris covered glaciers. So actually the one size fits all kind of approach or strategy for monitoring of glaciers here does not actually work. So this needs tailored approaches for, or glacier-specific approaches for monitoring, which again, complicates the monitoring or, very quick monitoring of glaciers. Next in the line is, as we've heard in the trend-setting, I think talk, that the sparse infrastructure. That is be it the meteorological sites, high altitude meteorological sites, or hydrological gauges, or even the field stations. So there is they are located very sparsely across Himalayas, which hinder the long-term time series of data, which is essential for monitoring efforts. We have been for modeling efforts, we have been like Dr. Kulkarni has shown some modeling results, but as our secretary was also talking in the morning, that many of the modeling result predictions and what is actually happening has a lot of difference. So the areas are warming much faster as than what was modeled, which may be because of the fact that these models actually need inputs. They need to be trained for prediction of the future. But if that data set is not available, it is difficult for the models to actually predict what's going to happen in the future. So that's one. Last is, as we all know, that these regions are very vulnerable. And in the recent times, there have been occurrences of, climate extremes, and which these climate extremes basically, the flash floods or blow-offs, they introduce a lot of unpredictability. And this unpredictability is, very, important when we are going for planning of the water resources or managing of water resources, especially for the downstream regions. So these are the four basic points I'd like to add. Yeah.
Thank you very much. I think it's very important to have good observations from ground so that we can have reliable model predictions. So now my question is for Professor Rijan Bhakta Kayastha. So recently we have witnessed several disasters in the region, like thawing Glof event in Nepal. Recently we had Sikkim Glof event, and some years ago we had this Chamoli disaster. So you have been part of the mitigation measures in some projects in Nepal, specifically on Glof. So I request you to share your experience from there. What are the mitigation measures that you would like to share here with us, so that other countries can also use these mitigation measures to reduce the risk from Glof events in future?
Okay, first of all, I would like to thank the organizers of this Arctic Circle India Forum and ICIMOD also for supporting these plenary sessions. And regarding this Glof experience from Nepal, for your information, we have 2,070 glacier lakes based on 2015 glacier inventory data. And I think that has already increased to 2,370 based on 2023 data. Out of that 2,300, around 47 glacial lakes are potentially dangerous to Nepal. Out of 47, 21 are in Nepal, one in India, western part of Nepal means in Mahakali River Basin, and 25 are in China, Tibet. So this poses that we need transboundary cooperations. If something happens in Tibet, so they should inform to Nepal so that we can take some precautionary measures, or at least humans can be saved. I think that is very necessary. And next thing I want to emphasize here that, as many others have also mentioned, that we have very less observational stations at high altitude. High altitude means above 3,000, 4,000 meters. In case of Nepal also, we have just 5-6 stations above 3,000 meters, which needs to be increased. And in case of lesson learned from lowering 2 glacial lakes in Nepal, so we have, out of 21 potentially dangerous glacial lakes, we have already lowered water level of those lakes. One lake is called Chorolpa Lake in Dolakha district. That lake's water level was lowered by 3 meters in 2000, and which is still active, and it's, how to say, it's not potentially dangerous now. It's danger is still there, but it is not happening now, which is very good because we have already lowered down by 3 meters. And the next glacial lake is Imja Glacial Lake, which is in the Everest region. And that glacial lake water level was lowered by 3.4 meters in 2016. And that is also still functioning. So out of 21, 2 has already lowered down and 19 are in the process. And recently the government of Nepal has, through this UNDP, submitted GCA project in order to lower down another 4 glacial lakes water level. And in those water levels, lowering water levels, one thing I want to explain that they have kept the iron gate at the new outlet. In case of Chorolpa Glacial Lake, it's already 25 years old. Out of 25 years, one single day was not closed. That gate was not closed. I think we have to think whether we need such gate at that altitude. The altitude of that Imja Glacial Lake is 5,010 meters and Chorolpa 4,500 meters. And in those glacial lakes, when we lower down, the another good point or the lesson learned that we have to hire the engineering consultant or consulting firm that they should have some good experience and technically sound. Otherwise, it will be very difficult because at that altitude, we have to work in limited time frame because in monsoons, we can't work, and pre-monsoon and autumn, in October, November, we have to work. And at that lake, cutting and making one new channels, it is very time consuming. So in case of Chorolpa, it took 2 years, and from lesson learned from the Chorolpa, in case of Imja Glacial Lake in 2016, the government of Nepal has lowered in one season, means around 6 months. So those I think we have to consider when we lower the other glacial lakes. And next important thing is that in case of Chorolpa, it was very coordinated with the locals. Locals were involved from the beginning. But in case of Imja, it was not communicated, or local peoples were not involved from the beginning. So when we load such glacial lakes, we must include the community's involvement from the beginning to the end of the project. Thank you.
Thank you very much. I think Nepal is doing great in this direction, and thanks for sharing these mitigation measures. Very helpful, I think, for other regions. So in this line, I have another question for Mr. Rizvi. We understand that the lakes are increasing in number because of receding glaciers, and at the same time, they are expanding in volume. Now, what role should local communities, government, and policy makers play in this direction to mitigate these GLOF risk in the region?
Thank you. I'm just worried about that clock. It's like a Tom Cruise movie. It's about to blow up. The whole train might just go up in 12 minutes and 37 seconds, but I shall try to make the most of it. As Her Excellency, the Prime Minister of Iceland, mentioned the excellent term of water power, that is something which we went towards, and a very big problem that she initially mentioned about data scarcity. So when you look at glacial lakes, the Indian ISRO, which comes under the Ministry of Earth Sciences, where Dr. Shukla works, they have mapped out in 2023 28,000 lakes above quarter hectare in the Himalayas, of which 25% are in India. That's a small number of 7,500 lakes, which are a problem for us. And the big ones we had were in 2013 in the Chorabari Lake and 2023 Sikkim. So these two are wake-up calls. So we did wake up big time. We have a large disaster management fund. It's about for 5 years, $30 billion. It's divided into 4 windows, 10, 20, 30, and 40. So the 10 comes for capacity building and awareness, 20 comes for mitigation. The rest is for relief and reconstruction. So I won't go there. So if you look at 20% for mitigation, it's $6 billion over 5 years, about 1 to 1.2 every year. So last year, we've sanctioned $1 billion worth of mitigation, pure mitigation programs, like the one that Dr. Rijan was mentioning, not just for glacial lakes, but for the 15 to 17 hazards that India has a serious problem with. So given the size that the country has, I will only speak about the glacial lake part. So we have a program for the 4 states that are seriously impacted. If you start from the west, you go from Himachal to Uttarakhand, and then Sikkim, and then Arunachal Pradesh. So we mapped out that which of these 7,500 do we go to, the kind of problem that Dr. Shukla was mentioning. So we went to all the agencies over the last 10 years that had studied lakes of which they said would be trouble. So we found 5 government agencies and 3 international agencies that had been working. We collated all their reports, and we found that several of the lakes were being studied by most agencies. So we asked them why. So they all said that these are the reasons: that it's expanding very fast, its moraine damage, slope stability looks very weird. So we started grading them as A, B, C, and D. So now we have a list of 200 out of these 7,500, of which we have A, B, and C, roughly 40, 40, 40. And then last year, we encouraged the state governments. As you know, that India is divided into 36 jurisdictions, 28 are states and 8 are union territories. So we requested the state governments that it's your lake, it is your water, it is your resource, it can be your problem. We are there to help you technologically, any international help, any local help, any of the 160 institutions that Madam's ministry runs. We will bring them together and help you mitigate the risk of these lakes. So we went, all the states have put out 40 expeditions in all to these 200 lakes in just the summer of 2024. So those 40 expeditions, they just got that 4-month window from May to September because of the freezing temperatures. Most of them are above 5,000 meters. So these expeditions went, several of them have come back with good quality data. The second, this is part of our assessment, our risk assessment. So the second big thing that we are doing is, again, what the Prime Minister mentioned, was early warning systems and automated weather and water monitoring systems. These have begun to be deployed. 2 of the lakes have already got them in Sikkim, Shakocho and South Lonak. And we are working with CDAC and ISRO to build more systems for the other lakes. By this summer, I think at least 10 more lakes. And then every year, drop by drop, we are going to make an ocean out of this, the kind of data that we will have. And this data we intend to share as much as we can. And once we do that, it will be a great contribution to the cryosphere data scarcity in this area. Mitigation is the third big aspect that we are working on along with communities, is to figure out how to reduce the water in these lakes, either by siphoning or by pumping, or the gate method that is used at Imja and Shorolpa by Nepal. We've been in discussions with our partners in Nepal and Bhutan, very deep discussions with those in Switzerland, in Peru, in Tajikistan. So we have been marching ahead in the last 2 years, fingers crossed we don't get any more gloves this summer and the next summer. By the next summer, we are going to be fairly confident that these 40 lakes will be fairly well defended and the communities will have good quality early warning systems in the downstream. Thank you.
Thank you very much. So we are running a bit out of time, but my last question for Dr. Pema is very important. So I would request him to answer in a minute. So we understand that the ice in the Arctic and the Himalaya are interconnected and they have a strong bond actually. And now the question is how we can connect the scientists working in these two different fields at distant, and what Arctic Circle, what role Arctic Circle can play in that?
I think the issues were brought out very clearly that the Himalayas, the Hindu Kush Himalayan mountains, the glaciers up there should be treated as a water bank. Now the melting is of course taking faster here because of the elevation dependence, about 2 times faster than the global average. So all these facts are known. And what we also need to know is that mountains are multidimensional. They have north face, south face, east face, west face. So we need to have a collaborated effort, coordinated effort, if you are to protect the mountains and they also reduce the rate of glacier melt and so on. So ECMOD is not a research organization per se. We do not have in-house capacity to do all the research, to all the monitoring. But what we do best is bring together the findings, the scientific evidences that have been generated by scientific institutions, both from within and outside the region, put them together. So this assessment, again, the first Hindu Kush Himalayan assessment report was inspired by the Arctic Circle's work. I think the first recommendation from our meeting in Reykjavik was to carry out this comprehensive assessment. So which came out in 2019 in the form of HIMAP report, Himalayan Assessment Report. And then 2023, we followed it up with another report called HIWISE, Himalayan Water Ice Society and Ecosystems. Again, bringing together the impact of ice melt on the society and on the ecosystems. So here, what we do is not only engage our scientists, but also bring experts and scientists from across the globe, then who could contribute to the assessment report. And that is one way of taking stock and then identifying the gap, the research gaps, the information gap, and then getting the expertise from across the globe, from the region, to engage in this kind of collective or collaborative research. So I think we need to do put in more efforts into building partnerships and building this kind of coalition, because at the end of the day is, as everybody says now, everything is interconnected. What happens in the Hindu Kush Himalayas matters elsewhere as well, and what happens in the Arctic matters here just as it matters there. So we need to work together. Thank you.
As our contribution, we've sent you one of our best.
So thank you very much. We can open the floor for the, questions from audience. So,
hello. My question is to Aparna. You had mentioned that I think Secretary Ravi Chandranji also said there is a discrepancy between observation and prediction by the models. That's basically because we are using WRF model and other GFS model which have a resolution of 3 kilometers to 9 kilometers. But in the mountains, each valley has its own orography and landscape. So there, these models won't work. What we need is valley-based models. And to have the valley-based models, we need to have dense network of observations. And again, as far as observations are concerned, most of the observatories, we have a bias toward valleys. And we have very less number of observatories beyond 3,500 kilometers. Even if there are some observatories, there are certain issues with because AWS may be not very robust. So we need to have robust AWS and more network, especially above 3,500 kilometers, and then have better valley-based models. They will be able to capture the actual weather. Thank you.
Thank you so much, sir.
so
Actually,
very quick.
yeah, so
response.
that's what I wanted to emphasize, and this is why when we are a funding agency, so when we are funding the project, especially in the valleys, that's how the researchers, they ask for AWS, right? So that is a requirement in that, and that's very important. So that's what I wanted to emphasize. You've aptly put it again. Yeah.
So another question from that table. Please frame your questions in a sentence or two.
So first of all, good afternoon, panelists and all the members seated over here. This side Ujjwal Bajpai, first year student of undergraduate program. And my question is, how can interdisciplinary Arctic research combining climate science, policy and economics be made actionable for disaster-prone countries like India? Thank you.
So who wants to take this question?
May I? So
Yeah,
please. I can say from the policy side that you're a young man, you're in the first year, and you have brought in 4 different 10-day conferences together in one question. It's all very difficult. It's definitely a policy question. And this is where you've got to bring the science, the policy makers, the international workers, and the different kinds of science and a different kind of policy, bringing it all together is the big problem that every government in the world faces. What I mentioned about what we do for disaster management, it goes for every single hazard. It's taken me 2 years to understand what exactly goes on in just glacial lakes. So imagine what happens in riverine floods, urban floods, flash floods, what happens to the monsoons where Dr. Sharma from the IMDs, from that organization. It's a huge task. So it's very difficult to put it in an answer. And after this, I will definitely seek time from you and we will have a chat.
Yeah, the last question, please.
Very quickly, I know it's a discussion on ice, but I just wanted to bring up the topic of permafrost, either in Nepal or the Jhelum Basin or Qinghai Tibet, which is the largest alpine permafrost region. Is there sufficient work being done, given the seismic activities as well, to anticipate disasters due to permafrost thawing in those regions?
Any quick response, Dr. Pema?
Yeah, maybe I'll take that question. I think we have to remember, while we can learn from the Arctic experience, the scientific work done there, we have to remember that the construct of the glaciers, the topography of what we are dealing with in the Hindu Kush Himalaya is very different from what we are dealing with in the Arctic. So here we talk about permafrost, very pertinent now. Only now we are realizing that permafrost study is very important, because when the ice underground melts, the whole slope comes down. The slope failure is going to be very common. Now there's quite a bit of work done in the Tibetan plateau, but again the topography is different. In the southern slopes of the Himalayas, now we have to be more and more concerned with permafrost melt. And I think now ICIMOD have just started some pilot studies, but we will be putting together the assessment of our state of the state of the knowledge on permafrost, and more investment need to be done in this permafrost.
That was the cause for the glacial lake outburst in South Lona, where the permafrost melt on the sides. It's 6 football fields length of the slope fell into the lake and caused 33 million cubic meters coming out.
Yeah, so I think we continue the discussion during tea break. So I would like to thank the organizers, Observer Research Foundation, and especially to the Arctic Circle India Forum for inviting ICIMOD to have this session. So thank you very much.